Good morning, everybody. Thanks for joining us here today. It's a real pleasure to be here at the RTC at this event here. There's a lot of groundswell going on, a lot of good activities, and just great to see everybody and to see the progress that's being made. My talk here today is one that I've been giving this year around some of the NENA and APCO conferences, and it's a topic that I think is going to be really important, especially as we move forward over the next few years, and that is communicating between Esinets. Okay. So I think that this is an important topic right now because Esinets are being built around the country. Right? They're being built in large jurisdictions. They're being built in regions, and they're also being built in states, right? So, and yes, we have standards that that the NG911 core services and the signaling are supposed to meet. But as we know, when we have standards, there's a lot of optional fields in the standards. So a lot of integration and test needs to go into when we start integrating different systems together. And so I think this is going to be something that's going to be, so it's more of a forward-thinking topic here today, I think, because we're just beginning, right, to stand up these Esinets around the country. And it's going to take a little bit of time, but then pretty soon, right, the selective routers are going to be gone, all the legacy infrastructure will be removed, and then we're going to have to communicate with one another. Different vendors are implementing these systems around the country, and there's a lot of integration to do. So this talk here kind of talks about some of the issues that I've been seeing, and I wanted to, kind of start a conversation with everybody. What I usually do when I talk about NG911, I like to start off with what I think are the value proposition, and these are the 5 things that I've come up with that I think are the most important. Today, really, we're going to be, in this talk, we focus in on the middle one, which I think is all the others are important, but this one here, being able to share information, right, is going to be key. Today, when PSAP goes to transfer a call that really shouldn't have been at their PSAP, but maybe at a neighboring jurisdiction, what we find is that so they have to transfer the call. Well, and pretty much they lose all the information that they've gained from the caller to that point. Right? So what we really want to do is improve the ability to transfer calls with the information. We're also going to have to be able to make sure that we route the calls to the right place, right, to the right PSAP. So certainly a lot of things that we have to be careful of as we integrate these systems. I'd like to also start off with just getting everybody on a level set. Okay. So these are what I think are the building blocks of a next-gen 911 system, and there's really five pieces to it here. The service providers are key because that's where the calls originate from. We've got to get those from the public, and we've got to get those to the PSAP, which is down at the bottom of the diagram, right? So in the middle there, we've got basically with an NG911 system, we gain the ability to host the equipment and the applications and the software in a centralized location rather than at the edge at every PSAP. Okay? So we gain some economies of scale, and we're able to deploy these applications in a hosted manner. Now remember, what we're doing here is we're actually replacing legacy infrastructure. Okay? And I've got a whole lot of set of other diagrams that go into that, but that really wasn't my purpose here today. But I think it's important to note that it's going to be a transitional environment, and that's going to play into communicating between Esinets as well. Okay, we still have the legacy infrastructure. It's going to be there for a number of years, so we have to consider that as we go and start communicating between Esinets. Now, when I think of NG911, and I said Esinet's a term that people might be aware of. How many folks here are aware familiar with NG911? Good, good. So we know the Esinet, right, is nothing more, it's very important. It's the end-to-end IP network, right, that has quality of service and resiliency built into it, right? So the Esinet, and you can see it, it's got a little cloud here, a little nice little bubble in the middle. It's more than that, right? It's not just, this, you could say to yourself, oh, that's the wide area network, and that's it. No, the Esinet is actually end-to-end. So it's the networking gear that's at the PSAP. It's also the networking gear that's in the data centers that connect these servers, routers, and switches. Okay, I think when I think about an Esinet, there's a lot to be done in the data center. That's where we have our domain, what we call our enterprise networking setup, and this is where we run the domain for a particular Esinet to route amongst the PSAPs. So on top of the Esinet, that thing that connects the Esinet to the PSAPs functionally is the NGCS, or Next Generation 911 Core Services. These are the set of applications that reside in the data center, right, that allow us to replace that legacy infrastructure. So we're doing geospatial routing of calls, right? So in today's world, the calls are routed based on a tabular approach. Your phone number, we look up in a table, and we find a route. Well, and with the advent of cellular phones, over 80% of PSAPs are taking wireless calls today. Over 80%. So, and with wireless phones, we're mobile. So we need to route based on location, right? Not just your phone number, because when you got your cell phone number, your cell phone number might tie back to your home address or business address. You're not there. And also, so today, phase 1 and phase 2 location routing, right, basically ties you back to the cell tower. Well, you're not there either. So, location really does matter. And being able to route a call, an incoming 911 call, from the public based on your location to the right PSAP. Now, what we're doing there is we're going to improve that ability of routing the calls accurately. So I'm going to reduce the number of call transfers that I have to do. Okay? We're still going to find that we need to do that. But by routing accurately, we're going to reduce the number of transfers. When I look at inside the data center, when we look at implementing the Next Gen 911 system, there's a lot of components that we need to have. And I kind of reflect that in this diagram a little bit. So we've got the core services. They're the I3 compliant pieces, right? The border control function, the emergency services routing proxy, and the others. So they're a piece of their software that runs on servers, and they are they represent what's in the standards for the NENA I3 environment. Now, but you have some other pieces that are critical. The transitional piece is going to be very important. We talked about that earlier. There's going to be legacy infrastructure. In addition, what we're seeing is that the service providers are not going over to SIP right away. Well, and there's a number of reasons for that. A lot of it has to do with why should they change, right? They've got infrastructure in place. So we have to be able to interface with these legacy interfaces, whether it's SS7, PRI, or what have you, right? So that transitional piece is there. The other piece is that it also interfaces with location databases, such as ALI databases. We need to get that data into our system. And so basically when we do that, we're not taking the ALI records, the automatic location interface data. We're actually, what we want to do is take the SOI records, the service order input, and we want to build our own location database. So that's really more of the interface that we're looking for in that transitional environment. The enterprise services, we talked about that. That's providing your domain, your DNS servers, your time. Of course, time is critical, right, for logging. Make sure all the logs have the correct time. The DMZ, demilitarized zone, that's a component up here that I think is really important too, especially as we talk about communicating between Esinets. And we're going to see why coming up here. So we'll keep that one for the next slide. The other piece that's on this diagram, I think that's important when we think about it from a solution perspective, and we're going to talk about this later, is the Network and Security Operations Center. Someone who's monitoring the system 24/7 by 365, not just monitoring it for the sake of monitoring, but proactively monitoring it, right? Being able to see, are there differences in traffic patterns from day to day? Are there certain errors that we're seeing accumulating? Do we need to take action on those, right? So proactive monitoring is really important. And also security is going to be important too, especially as we think about connecting Esinets together, okay? So this slide here, what I like to do here is, now I had a whiteboard, I start drawing. As an engineer, love to draw. But what I want to do is keep it a little simple here today. So when I think about Esinets, when I say Esinets, I really mean the core services and the Esinet, right? So they go together, okay, right? The NGCS rides on top of the Esinet. And there's really three different systems, right, that we see out there for next-gen 911 systems. The first, so we're seeing regional Esinets, right? So, for example, let's say I've got a state, and actually I think Illinois is going to be a good example, because what we have is you have, let's say that we've got a group of PSAPs, a dozen, maybe 2 dozen, right? They're in a common area. They pooled their money together, and they want to implement geospatial routing and all the things that NextGen brings, IP-based functionality. And they got together, and they created their own Esinet, created their own NextGen core services, populated the databases, and turned up service. Okay, so that's one region. That's great. And the PSAPs next to them are still working off the old selective routers, right? Now there's another, let's say there's another region turning up in the state, right? Again, they got their own area, they've got their own databases, maybe the same vendor, maybe some other, maybe there's some changes, maybe the same vendor, but there's some changes in the components. But these regions, right, eventually they're going to need to communicate with each other at some point, whether it's to transfer a call, maybe to do a route query, and how do they do that, right? So what we think is that there's a concept in the I3 specs called Forest Guide, okay? And this is really nothing more than an ECRF, emergency call routing function, with the location validation function. So those two go together, right? And you want an authoritative ECRF, LVF database. The ECRF is the component that actually does the lookup, right? Based on location, it says, you draw a map, right? And you say that this location is inside this polygon, so therefore it gets routed to PSAP number 1, okay? So the ECRF is the key function that does that routing, that determines that routing. So what you want to do is when you have multiple Esinets that need to communicate with each other, one's got to have an authoritative database, right? To say, this is the data that we need, that we all agree is the valid data set. So if you have 2 regions within a state and they need to look up, do a route, does it determine, is it mine, does it go to them? Well, why not have a statewide entity that has that authoritative database, is what it might look like, okay? It's one idea. Now, of course, you could also say that each region, that maybe they've got their own authoritative database and there's nothing in between. Well, that's not really the solution, right? We've got to have some ways to communicate. And we'll see what that looks like. There's another example, I think, when you talk within a state, a hierarchical Esinet, okay? So, for example, let's say that, so we got these regions within a state. They found the money. They wanted to go to NextGen 911, but the state wasn't there, right? So the regions got there first, or maybe a large jurisdiction. They did it first. Well, but then the state says, hey, you know what? We've got our act together now. We're going to provide a statewide Esinet, but this region or this jurisdiction already has one, right? So that could, to me, that's an example of a hierarchical one, right? The state, The state is going to have their own systems. They'll have their own authoritative data, but that region or jurisdiction, they can have their own ESInet for their and authoritative data for their data set, for their population. Okay, and when they want to go outside it, they actually query the authoritative database, which is up at the statewide, at the one hop up, right, at the state level. So we've got that. And the third kind that I thought of was just a neighboring ESInet. Now, this actually covers the regional, but it was really meant for between states. Okay, and that's where I came up with this hierarchy chart here, right, where you see that I've got jurisdictions, and a jurisdiction can be on its own, or it could be part of a region, right, or it could be part of a state. Right, the region's going to be part of a state, and then there should be, so I've got multiple states, right, and of course we have our nation here, but there's nothing nationally, right? That's why it's dotted line there, right? Because there's nothing mandated to have a national ECRF or any of this for the forest guide, right? But certainly there's got to be some way to query between NGCS systems in different states. We're gonna have to get there at some point. Okay.
There's no mandate currently right now for the state of Illinois. Yeah, either is that.
Not in the state. Barbara, can you?
As far as those databases, no, but the state has, by 2020, to have a statewide network.
Even though we're putting silo Esinets up everywhere.
Right. In other words, think of it like two regions now, and no state.
Sorry.
And
Oh no,
else.
this is what we want. We want
No,
to encourage this.
And then, I thought that we're going to run into next door neighboring states who we should be already talking to.
Yeah.
So I think more of a peer-to-peer relationship than this hierarchical model, probably having to be built long before we get a hierarchical model that's functional.
Yeah.
And again, don't be afraid of the silos, right? Because when you think about it, I mean, let's go back 15, 20 years, 25 for some of us. Nobody had email. Very few people had internet access. One day, Tom walked in and he had email available to him. Another day I walked in, I had email available to me. But for us to email each other was not always as simple until the internet happened.
Wireless started out the same way. That's the
Yeah.
model I use.
Yeah.
Cellular networks were built as little regional models.
But the key is interoperability, and that's where the NENA I3 model is. So when Tom presents what's a NENA I3 specified model, it doesn't matter what my neighbors build. If they build to this model, it's linking them together, and everything flows. No one needs to know what anybody else is doing.
Yeah.
It all just works.
Right, but I mean, that's a theory.
Yeah, theory, yeah.
But we haven't, the uniqueness of implementations still precludes the fact that we're gonna have a seamless interoperability, whether it's this way or whether it's that way. I'm just
Right.
saying.
But ideally, it shouldn't matter.
It should work, it
Right.
should not matter.
Right.
But, I'm sorry, I shouldn't be talking so much.
Oh no, we want you to, Mark.
But this, I think it's gonna take some work, and we're almost at that point. We really are at that point where we need to put things together.
Yep, and that's totally right. Yep, and that's the reason that why I brought this topic up and wanted to bring it up and to share it with everyone, is because it is important. And I think you're right, Barbara. I think we're going to see a lot of peer-to-peer relationships, but I also think we're going to see this hierarchical one. So, for example, in my home state of Virginia, the National Capital Region is made up by a number of counties in both Maryland and Virginia. They're surrounding the nation's capital there, and they're pushing forward. Like I said, so they're not waiting for the state, but we know the state is right behind them, right? So there's going to be an example there of that top,
It will happen.
that up and down communications, right, as well as the peer-to-peer, right? So, and we see that from between regions within a state and between states themselves.
Tom, let me ask you a question.
Absolutely.
Do you see anything happening at the federal level to provide that federal national glue that would be there to link entities in North America at a state level?
Right. Well, I think we have the manner, the definition to do that, but we're not seeing the drivers. We're not seeing it driven. So it's this ECRF,
The architecture's there,
The architecture's there, and it's defined.
but who's going to pick up? Who's going to be the national backbone?
Exactly. There's no one there today. They're not talking about that right now, right? So we've got the ability to do it, but we don't have the ability to execute, right? To actually do that. So, and that's another reason that I wanted to bring this topic up, is because I think, especially as we talk about communicating between states, we've got to have that. We've got to have that national perspective, that or some kind of a, because what it's going to come down to again is authoritative data, right? So does that mean that the feds have everyone's geographical data? Well, that's going to be a barrier, I think, right, to adoption. In a lot of cases, because a lot of folks just don't want to do that.
Just one thing I
Yeah.
think I read, and maybe it's wrong, but I think I read that Walt Magnuson has been part of a project where they've been working with Mexico
Mhm.
and bringing them together. So there are probably examples out there that we're just not aware of. And I'm guessing that Mark Grady has also done some of this with this Indiana,
Mhm.
Ohio, Michigan collaboration that I'm just not aware of.
Gotcha. Yeah. Yep. So definitely see that. Now this diagram here is going to be my more technical one, and it really shows you the elements that are part of the core services, okay, that would interface to external entities. So over there on your left-hand side, you've got the external world, right? So those could be a neighboring ESInet. They could be, they're going to be SIP service providers and local jurisdictions. And that covers the case, whether it's hierarchical or whether it's peer-to-peer. So these guys, so what do we have to do when we want to communicate between ESINETs, right? So that's really what this chart addresses. What is it that we need to do? Well, there's a couple things I see, okay? And I'd like to get your input too, if maybe I missed something. So one thing is we've got to be able to transfer calls, right? Actual signaling, right? So that's kind of on the bottom one. And we've got the SIP, and you notice with EIDD. EIDD is Emergency Incident Data Document. We're going to go into that in one of the next charts. I think that's really important. That's how we share information. Okay, that EIDD is basically an XML data structure that can be passed along with the SIP invite that actually has all of the information that's been collected by agents to that point. Okay, so really important. So, and that's what's great about this, the signaling that we have defined by the standard, is that it allows us to share this information. It allows us to put in not just geographic location, okay, but the other, and you'll see the data structure. I've got a top-level view of it. Lots of information that could go, and it could help save lives by having that information the first time. So you collect it once, and then you're able to share it repeatedly, and you're not wasting the caller's time asking, where are you? What's your emergency? Twice, maybe 3 times, right? All that data goes with the call every time you transfer it. The other things that I think that we're going to have to do when we communicate between ESINETs there's 2 other things. One is do location lookups, okay? So maybe my database doesn't have the record. I can, if I know about my neighbor, maybe I should go ahead. Maybe part of the policy is to go ahead and look up in my neighbor's database. Well, what I would do here, and this is where the DMZ comes in, that demilitarized zone. The way that, and this is the way that we would design it, is that we would put these external elements that need to be shared with other entities, other ESINETs. If we would put those actually in the DMZ, right? So that they're not in our core, okay, but they're accessible to the outside world. Now, these databases, the external loss server, and there's the LDB. The LDB is the location database, okay? Right? Those functions, they get their data from the core, right? So, you're constantly updating them. And so they're active, they have the latest data, but they're just on the edge so that they can be accessed from the external world. So for example, a neighboring And I think that'll be more the case, maybe, or actually even a hierarchical. It doesn't matter. So one sub-ESInet or a neighbor ESInet needs to do a location query. They're going to do a held request to the LDB. Okay. So now let's say there's another. So that's another thing. So we got calls, we got location routing withheld. The third thing that I see is routing requests. Okay. So this is a case where you know it's not destined for within your system. Okay. So where should it go? So maybe this is a hierarchical sense, a hierarchical case, right? Where I've got my jurisdiction, we're right on the edge here, right? So right just outside my boundaries of my jurisdiction. So where should that call get routed to? So that system might send a loss query to the hierarchical ESInet, the top level one, to get the route and then forward the call onto it. That's possible. I don't think we have the mechanisms for that in place yet, but that's possible. Yeah.
Tom, I mean, another piece where additional data can come from are potentially enterprise commercial networks.
Mm-hmm.
Can you talk a little bit about the trust model from a security perspective? Because while this is great from an interoperability, it also presents itself with a huge attack plane from a security swatting.
It sure does.
DDoS, my God.
Absolutely, Mark. And that's actually something I cover coming up here. So that's a good point. I think security is a must, okay, especially when we talk about communicating between these ESINets, okay? So that's why, for example, that's why we would put these elements in a demilitarized zone, right? Because I don't trust. It's a trust issue, right, for one thing, right? These other ESINets, they're set up, they're independent of mine, but I do need to communicate with them, okay? And, so I may not trust them implicitly, but that's why I put things in a demilitarized zone. Now, there's going to be, I've got to do all the security checks that we've got to have, the policies to check the content, right? We've got to have security, encryption's got to still pass end to end, right? So there's communicating with the encryption. So I think those are some of the things that we'll have to really worry about coming up. But we'll talk a little bit about that more in a upcoming slide. But really good point. Security is a key part to all this as well. So any questions on this slide here? Okay. So again, these are, do you think I missed anything? Is there any other way that we might need to communicate between ESINets? So these are the ones that I thought of, and if anyone has any ideas, let me know. We'll update it. But this is, and these are the things that I think are important. Carol, yes.
Have you yet any experience with this?
Good question. And so not my company today, no. And that's the reason that we're talking about it, is because we're building them. We're building statewide systems, we're building regional systems, we're building jurisdiction-based systems. And I woke up one morning, or maybe I was going to bed or something, I was thinking to myself, hey, wait a minute, we're going to have to talk between these systems at some point.
Yeah.
Right, and that was the question,
Yeah.
because, I mean, we've built several in the lab ESINets.
Mm-hmm.
And we know even since when we began building them, we think of other things, and then we discover that the standards also change as other people think of other things.
Yeah.
So that was exactly
Yeah.
when we do the first of these ESINet to ESINet communications, we're going to discover more. So that was just the
Yeah.
question.
Yeah.
Have you done this once yet?
Yeah. No,
And-
not yet. So,
Yeah,
So
yeah.
definitely a forward-thinking kind of a talk here today, right?
Yeah, well, and we're
but-
going to have the panel this afternoon discussing the possible barriers to this kind of thing, so
Yeah.
I'm sure you want to be on that one too.
Good, yeah, and I see this is definitely one of them, right?
Yeah, yeah.
One of those barriers. Mark?
Tom, another question, Tom. I think it's great that we have all this internetworking, interoperability in place, but
Yeah.
what worries me is we have to change our thinking. So if I'm going to ask your company to build a 5 nines reliable network,
Yeah.
you as an engineer have got your checklist for resiliency, redundancy, multiple paths. You can build that for me. If I'm going to start adding in adjacent networks that I don't necessarily have control over, enterprise networks, peer agency networks, how does that affect, how do you see, because this is subjective, how does that affect me calculating my nines? When you've got great data, let's say I know Barbara's got great data, but Barbara only has a 2 nines network, because that's what she's got. How do I calculate that, or should I even be worried about that?
Well, you know, I don't have the answer for you off the top of my head, Mark, how to calculate that, but I think it is something we have to think about. I really do. So, for example, the other network might not have dual entrances, right? It may only have one router, you know, one interface. Well, and so I definitely have to calculate that into my equation, for sure. Especially when we start talking about the ability, now it's fine within my own system, right? But once you say, now I've got to communicate with this other Esinets, now you definitely have to think about that.
The FCC task force that I sit on is doing interviews with PSAPs on Esinets, lessons learned type things. And a common thread that's coming up is, well, we've got a PSAP way out in the middle of no place, and the only thing I could get was commercial broadband cable. It was the only connectivity. Is it what I want? No. But it's the only thing that I can get. So it's a point that I can't count on. Most of the time it works, but
Most of the time it doesn't.
It's a reality, right?
Right. Yep. And because we see a lot of the smaller PSAPs. So you may have that one, and may only have that one bit of fiber or that one cable coming in, right? You may not have the redundant access that we'd like to have, right? So you definitely have limitations there.
I just was interested in your thoughts. So what should you do? Just get as much as whatever you can and call it a day?
Carol, what do you say? And then I'll
Well, one thought about this, which we've had to deal with in our own, in our own development, is this is a question of saving lives, right? So if you are not a 5 nines, if you're a 2 nines, but you have information that's going to save a life, then you try. If it doesn't come through, then you forward, of course, based on what you do have, and that's what we had to do. We are doing indoor location. So if we don't, for some reason, come up with the indoor location, we send the 911 call based on as much information as we have. There has to be something like that in a standard. You can't afford not to try to get the information, but then you have a time cutoff, and that I believe something like that has to be in a standard or a spec, right? Yeah. You make use of, you give it a shot. So if it's not a 5 nines, you're not going to not use that data.
I think that's an interesting point. The way I would look at that is that, so for example, I might want to transfer a call with that EIDD, but maybe the other system doesn't, right? So at least I'm going to deliver the SIP call, right? I'm going to at least deliver the ANI, right? And the core information that I had in the call. So you got to do what you can.
Question in the back from Bill.
There we go. That's on. Hey, it's not so much a question as much as a contribution to that last question that you
Bill,
asked.
we are broadcasting, so just introduce yourself quickly.
Oh, yeah, okay. So I'm Bill Mirka with Motorola Solutions, but obviously I think most of the people in the room who know NextGen 911 know that I'm very involved with NENA, European Number Association, a lot of other global organizations. I've been doing this for the last 5 or 10 years. So I think the name, at least to some people, is probably fairly well known. But I wanted to comment on the statement that you made about connectivity with cable and DSL and things like that. And I was just going through the agenda to make sure I wasn't covering something that was already in the conference. Maybe this will be something for a future conference. Maybe it's already been covered. The people who know networking probably already kind of know a little bit about the topic. But there's been a change, right, in the way that network services are offered, not only in carrier cores, right? Anybody who's from a carrier is familiar with the concept of software-defined networking and network function virtualization. But what's happened recently, and Tom may very well know this from work that GD already does in other sectors. I don't know if they've brought it into NextGen. Certainly Motorola and other vendors have certainly looked at it. I don't know if it's been commercialized yet. But PSAPs all around the country, one that's public that's already taken advantage of SDN technology is Maricopa County, Arizona, right? So there are vendors in what's known as the Enterprise SDN or Enterprise SDN WAN space who are taking some of that technology that heretofore has really only been in carrier cores, and what it's allowing people to do is exactly what you talked about, right? Not even in areas where you only have that kind of capability, but if you want to be able to buy cheaper connectivity and avoid the rigmarole and the expense of some of the more expensive carrier-based solutions, people literally are buying cable and DSL connections. They're putting enterprise SDN solutions, boxes, VMs, instances for AWS. It can be run in a lot of different ways, and they're adding that quality of service and reliability and assurance that you get from a more expensive carrier solution with cheaper transport, right? So those solutions are out there today. Some people may think that the vendors that supply them are brand new or that this is new stuff. It isn't, right? So the leader, and I'm not going to do any advertising here, but there was someone on the NENA floor in June from the space who's been selling these boxes to several PSAP jurisdictions. Connectivity's come a long way, so just because you're in an environment where your base transport may be cable or DSL for broadband, there certainly are ways to juice that to be next-gen 911 quality if you can't get anything other than that as base connectivity. I just wanted the audience to know that.
Yeah. Bill, I think that's a really good point. Software-defined networking, network function virtualization, those are things that are near and dear to my heart. The SDN functionality, I see what the advantage of that, what that's bringing to the table is to bring that end-to-end quality of service, right, across these disparate transports. So I think that's a really important technology to deliver that. The network functional virtualization, I think, is going to be key, especially as we start delivering more systems that are maybe as a service, something where I can scale in my data centers, right? So really, really important technologies there coming to the table. Did we cover the question? Oh, go ahead.
Just a comment. EIDD, we will be testing EIDD here with I7. That's going to take place in March of 2017. So IIT is going to host I7, and
Awesome.
EIDD is one of the apps that we'll be testing.
I'm so glad to hear that. I hope I get to come and and see and witness that. I think that's critical. That's great to hear, Joseph. Thank you very much.
Just a question right behind you there.
Yeah, I just had a question around the data centers.
Yeah.
So I'm with US Cellular. We've been receiving an influx of data center notifications from different vendors who've been awarded that work per state or per region, whatever the entity is. I wanted to ask, are the data center vendors' roadmap also to include the ESInet in most of these cases or not? We've only seen one or two of them where they have, but not all.
The data center vendors themselves. Well, for the way I see it is that it's really just a location for me.
Plumbing.
Yeah, but I got to have it. It's important, right? You got to have the power, the HVAC, and the security, right? And the other thing about data centers, points of interconnect. I've got to be able to pull in all my different points of interconnect with many different carriers, right? As we go away from the selective router, because my data centers now are the selective routers, right? So I've got to pull in all that traffic from all the different providers. So the data centers are key, but they're just a location for me. Like if I'm delivering as a service, I could have data center in California, one in Virginia, and I could be serving populations all over the country with those, right? So.
Understood. I think my second question would be around 911 rating. So as far as the funds that are given to these states and regions to put emergency services in place, has there been any gates or any roadblocks put in place so that the funds are going directly towards building?
No.
Well, I mean, one thing I can say. So I sit on one of the committees I sit on is the FCC Task Force of Optimized PSAP Architectures, and we went through and included heavily in our reports all of the recent major rating issues. One of the things that our committee found, unfortunately, was that there were some states where it was actually well documented within the legislative statute for the state to be able to raid that 911 fund. So you've got people like New York that collected $1.4 billion over the last 5 years, and only 14% of that went to 911. And then you've got other states that were probably just as bad, but right there in the legislature it said, you're allowed to take this money. So you can't blame them for taking it. It's awareness, though, because the public won't stand for it.
Yeah. And what I'm seeing is across the map, right? There are some states that don't have any 911 funds at all.
Yeah.
And then there's others who are building keep. Then you got the others who are who are raiding the raiding the statewide funds. So it's all over the map. That's what I'm seeing. Carol.
Thanks. And this afternoon, we'll have a panel discussion about some of the barriers, and that will be one of the things that will be brought up. It'll be right after the, I think, in the session after the keynote. So this afternoon, Admiral Simpson will talk from the FCC about this NG911, but right after that, there'll be a panel discussion, all the barriers. So please attend that too.
Yeah. Good questions. Okay, great. So I'll go ahead and next slide here. I've only got a couple more pieces of information to share today, and I'll go ahead and we'll do the next thing on the agenda. But the emergency incident data document. Here is a copy of what the data structure looks like visually, and when we look at it, we can see that it truly is collecting not just data from the call, right, but from the agent, the call taker, his information as well, and things that person was able to document. So all these different things, whether it's about a vehicle, whether it's about a location, whether it's about the dispatch, right, the equipment that they've dispatched, all that can be recorded in this data structure. And we're really looking forward, to seeing how this plays out. Because here again, we got standards, but there's so many different. I used to do SIP coding, and yeah, we got a standard 3261 for SIP, but there's so many optional fields. And when you go to interoperate, right, with another SIP provider. You always found problems. There was always stuff, right? So those specs, just because you have a standard, right, doesn't mean that everyone's talking on the same page. We got to be like this, and I think it's going to be interesting to see how does this data structure get passed between different vendors, right, between different solutions, and how is it presented as well. So I think it's going to be really interesting to see as we move forward. But to me, this is the key to sharing information, to sharing the incident information, right, between PSAPs. Any questions on this guy? So this is new, right? This is new. Yeah, it's in the V2 spec, and it's not fully defined yet, right?
No, that's
So,
part of the problem.
yeah, but we got the high level stuff here. Bill, yes.
Yeah, for what it's worth, among 50 other things that I seem to be doing at the same time, I recently became a member of the APCO Technical Committee. So we just this week we did the voting on the EADD spec. So I don't know what the results are yet, but that should be formalized within APCO. Since this is even though NENA and APCO did it together, as you know, it's an APCO spec.
Yes.
So it will be approved within the next couple of weeks here. So everything that's well, hopefully it should be, right? I mean,
Voting just closed on that.
Yeah, that's what I'm saying.
Yeah,
So I mean, because
just-
I got pinged while I was at NENA by
Yep.
APCO to vote on the dang EA. So I
Yep.
mean,
Okay.
so I just did that recently. So yeah, so Tom in the room, I mean, that will be approved. And Joe's right. I mean, obviously another one of the this isn't an advertisement for me. It's just information. I'm also the chair of the ICE steering committee for NENA. So I mean, it is important. What Joe told you is our current plan. EIDD has been part of the ICE 7 plan from the very beginning. So long as everything continues to track, this standard gets approved, there's no issues. We should be back here at IIT's Wheaton campus in March to do this test of all the things that should be formally approved here in the next couple of weeks at APCO. So
That's really great to hear.
yeah.
Yeah.
Just so you had the information.
Yeah, and again, I think this is really important because as these Esinets start proliferating, right, within a state, across states, within our nation, this is going to be a critical piece. Okay. So the next to last thing here, security. Mark brought it up earlier. Really important, right? You can't have a stool with only 2 legs, right? So you've got to be able to do your monitoring. Got it, right? You've got to be able to, and of course, see, defense in depth. That one there, that's really your firewalls, your antivirus, right? All your things. So you've got to have all your defense. You've got to monitor, but you also have to be able to, like I talked about earlier, be proactive and remediate what those issues are, right? So we've got so it's a whole set of policies, a whole set of tools, whether it's denial of service attacks, whether it's encryption end to end, right? There's a whole set of security issues that need to be addressed as we communicate between Esinets. Okay, so I think that's real key. Yes?
How does all this stuff work when the traffic's encrypted? I mean, I hear a lot about anomaly detection and all this stuff, and
Yeah.
in practice, if the traffic's encrypted, right, it's not going to.
Well, the packets get to the node that they're looking at, looking to reach, and we decrypt it once it gets inside the system, right?
So that essentially all that intrusion detection occurs on the end systems.
On the
end systems.
on the inside.
On the end systems,
On the
not in
end
the network.
system. END.
Yeah.
End.
Oh, end system. The encryption should be end to end.
No, but where does the intrusion detection, I think is Bernard's question.
Yeah, where does it happen?
Okay, well that's going to happen in my both my DMZ and in my core of the data center network.
But the traffic's encrypted, so it can't see anything. The traffic would be encrypted, so how does it happen?
Oh, well, I think it would probably. I would think it would. So the traffic is. So we do IPsec tunnels. Okay. So router to router. So once it hits the router, then it gets on the inside. Then it hits my IPS. Then that's so it's unencrypted at that point. I would think.
Well, yeah.
I think so. Yeah. It's
Yeah.
got. It's in. Yeah.
Not
The
if it's-
encryption.
Not if it's WebRTC, which is how all the emergency apps are being built. It's still
Mhm.
encrypted. Anyway.
Okay. Yeah. So I'm no security expert. Okay. So, but I know that we're encrypting tunnels from router to router. Okay. And within and I believe that's what the spec says, that we have to be encrypt between systems when you're outside of when you're outside of your system and going to another. You got to encrypt
So the
that
tunnel, the
traffic.
transport's encrypted, the
Yeah.
payload is in the clear.
Right.
Yeah.
Yeah. Okay. Good question. And then so I just wanted to finish up, by saying that so Esinets they are proliferating, right? They're being implemented all over the country, right? In jurisdictions, in regions, and in states. So I think we're going to have to be able to communicate between peers. We're going to have to we may have to communicate on a hierarchical basis. We may need to communicate within a state, interstate. Okay. We need to be able to transfer calls. We're going to need to be able to do location queries, route queries. We talked about the emergency incident data document, which is going to be key to actually transferring the data, the information. And the security is going to be a big thing, issue as well. Whether it's encryption, whether it's the denial of service, and other security issues. So with that, I just want to say thanks. It's great talking with you. I thought we had a good conversation here.
Yep.
And I really appreciate it. Thank you very much, everybody. Have a great day.